Hello, welcome once again to my channel. In this video, I'm going to discuss the topic mechanics. Mechanics can be seen in both physics and mathematics. And before you get to understand these concepts, mechanics, you need to know everything here so that it will help you to solve problems involved in mechanics. If this is your first time of viewing, consider subscribing to my channel to be notified whenever a new video is uploaded. So when we talk about mechanics, we simply mean the study of the effect of forces on bodies, right? So when you want to deal with the effect caused by forces, the impact of forces on various bodies, you are discussing mechanics. And mechanics can be of two types. It can be the dynamics or the statics. Okay, so when you talk about dynamics, you talked about the effect of forces on an object that is in motion. Okay, because dynamics means something that is moving, unlike statics, which is talking about objects at rest. So statics is the other way around, the effect of forces on bodies at rest. Okay, that gives you statics, while this one is dynamics. Okay, now, and for a body to be at rest, it means that it must be in equilibrium, it must be balanced for the force to act on them. So then we have the word or the concept mass. Mass is just the measure of matter in a substance, in a body. Okay, the measure of the build-up, the matter, the contents in a body will give us the mass of that body. Okay, so we have this mass is also a scalar. Okay, because it doesn't have a direction, and the unit of mass can be kg. That's the SI unit of mass, kg. So force is just a push or a pull. You can call the concept force a pull or a push. That gives us forces or a force. A force is a pull or a push. When I talk about push, I mean forward movement. Pull is backward movement. Also, you should know that force is an agent which changes the state of rest of an object or an object in uniform motion. So force can cause an object that is at rest to start moving, and it can also make an object that is moving to stop moving. An example is when you mash your brake, you see that a moving car will stop moving once the brake is mashed, and that is a force. You can also apply a force to an object that is at rest. The object will begin to move. Okay, so and the SI unit of force is the Newton. The force is measured in Newton. And you can have various kinds of forces. You can have the gravitational force, which is talking about the effect of gravity on a body of mass. You can have the magnetic force, yes. You can still have electromagnetic force. You can have the electrical force. So these are forces. Then weight. Weight is somehow a force, all right? The measure of the pull of gravity to an object is just the weight, because the rate at which a human being will be pulled down and the rate at which a piece of paper can be pulled down is not the same thing. Okay, so the measure of the gravitational pull of an object under gravity gives you the weight of that object. Weight is a force, so it can be measured in Newton also, just like the force. So by now you must have seen the difference that exists between the weight and the mass. So mass is a scalar, weight is a vector, and weight is just the measure of the gravitational pull of a body. We have particles. Particle can still be just a part. One of the smallest parts of a material, of a substance, gives us the particle. Then again, we have the rigid body. When do we say that an object is rigid? An object is rigid if there is negligible displacement of the particle of the substance. Okay, now take for instance, I have an object like this. Okay, now inward force, and so many inward force can be here, and you can still have a lot of outward force here acting on this body, outward, inward, etc. Okay, so all these things are forces: F1, F2, F3, F4, F5, F6. If I like, I can have another one which is pulling. Let me say this one pulling inside. Can call it F7, for instance. So if there is a particle here and another particle, let's say particle A and particle B, if it is possible that after rotating this object, the distance between A and B will still be the same thing. There is no difference. Even if there is a difference, it should be negligible. So if this is so, it means that this body is a rigid body. Okay, when there is no difference between two particles in it as a result of the displacement of the body. Okay, so we have the resultant. If I combine two or more forces to produce a new force which has the same effect in magnitude and direction as the original forces have combined together, it means that that force is the resultant force. Okay, so if I it's just like a result. When I combine vector A and vector B to produce vector C, which has equal magnitude and direction as the two other vectors that has been combined together, it means that that new vector is now the resultant, and we denote resultant vector by letter R. So to get the resultant of two vectors, we can use triangle law of vector addition as well as the parallelogram law of vector addition. Now, for the parallelogram law of vector addition, suppose I have, let's say vector A, and I have vector B, for instance. Okay, now the force or the vector drawn at the point of intersection of these two vectors represents the resultant vector in magnitude and the direction. Okay, so this vector I've drawn here, that is drawn from the point of intersection of these two vectors, represents the resultant vector. This is what the parallelogram law of vector addition is all about. Now, if I try to complete the parallelogram, I can get something like this. I'm trying to complete the parallelogram. So you can see that if here is B, that opposite sides are equal, here can be B, here can still be A. Okay. Now, if you wish, you can form a complete triangle here by extending this way, so that we can get an angle that is right. A right angle triangle has been obtained from here. Now, supposing there is an angle here, theta, it means that here will be 180 degrees minus theta. If you know the properties of a parallelogram very well, or the angle formed between parallel and transversal line. Supposing you have parallelograms like this. Okay, any angle here, if here is 60 degrees, automatically the angle that is here is also 60 degrees, because this side and this side are parallel to each other. Okay, and this angle and this angle are called corresponding angle. And this is an angle lying on a straight line, and the sum of angles on a straight line is 180 degrees. Therefore, to get this angle, I will say 180 minus 60, which will give me 120 degrees. That is just what I have done here to get this angle here, 180 minus theta, because the whole angle here is theta. Okay, so many things can be done here to get this particular angle here. Suppose I want to get the angle from here to here, I can call it alpha. Okay, so this alpha can be obtained following a well-defined trigonometric rules to get it. So you understand this, what I'm talking about, appropriately when we relate it in solving this particular question. So I will clean the board, and we solve this question to see the application of the parallelogram law of vector addition. Okay, look at this question. It says find the resultant of two forces of 24 Newton and 15 Newton at an angle of 50 degrees to each other. Okay, now let's suppose that this is the first vector and this is the second vector. The magnitude of the first one is 24 Newton and the magnitude of the second one is 15 Newton. And the angle between them is 50 degrees. So let's say 50 degrees. Now this can be the resultant. Okay. If I complete the parallelogram, I have a shape like this. Now, if I want, I can complete this to form a right angle triangle here, where the angle here is 90 degrees. And the angle between them, with the horizontal from here to here, is alpha, for instance. Now, remember what I told you according to corresponding angle. If here is 50 degrees, automatically the angle here is 130 degrees. How will I get this 130? 180 minus 50, because they are adjacent angles or interior opposite angles. The sum of interior opposite angles gives you 180 degrees. Also, you should know that here is 50 degrees, angle on a straight line, or corresponding angle to this. If this is so, it means that here is 40 degrees also. here is 40, here is 50, then here is 90, because the sum of angles in a triangle is 180 degrees. So what are we looking for? We are looking for the resultant R. If I want to get this resultant, I will bring out this particular triangle here. Look at the triangle I'm talking about. I want to get R. The angle here is already 130 degrees. Here is my R. Remember that here is 15 Newton. Okay. Now, if here is 24 Newton, automatically here is also 24 Newton. So I'll have here as 24 Newton. So to get R using cosine rule, when you have two sides and the included angle, I can now write that R squared will be 15 squared plus 24 squared. Okay. Plus minus 2 times 15 times 24, cos the angle here 130 degrees. Remember cosine rule, 15 squared plus 24 squared minus 2 times 15 times 24, cos the angle here 130 degrees. So R squared will give us 15 squared is 225. Let us get 24 squared. 24 squared will give us 576 plus 576. Minus 2 times 15 is minus 30. Minus 30 times 24 will give us 720 minus 720 times cos 130. Cos 130 will give us minus 0.6428. Okay. So R squared will now be 225 plus 576. 225 plus 576 will give us 801. 801 minus minus will turn to plus. So 720 times 0.6428, that will give us 462.816. So R squared will now be, we add up, plus 801. So it will give us 1263.816. So finally, to get our R will now be square root of 1263.816. So let's get there. Square root of 1263.816. It will give us 35.55 Newton. This is just the resultant force. Okay. Now, we cannot, because this is a vector, we can not only stop at getting the resultant force, we still need to get the angle, the direction of the resultant force. And to get it, look at this triangle here. If I get the complete triangle like this, this is what I'm having. And the angle here is just alpha. I'm getting this triangle here. While I have something like this, where this is 130 degrees, this is 50 degrees, this is the right angle, and here is 40 degrees. Remember, here is 15 Newton, and here is 24 Newton. Okay, now if I'm to take the complete triangle, now let me click clean here for proper illustration. So a good look at this triangle will tell you that my angle here means this side over this side. That is, here is the opposite to this angle. Here is adjacent. So if I take opposite of adjacent, that is tan. Hence, tan alpha is, let's say here is this opposite is y, for instance. Tan alpha, I remember this 15 Newton is just from here to here. Okay, from the diagram, from here to here is 15 Newton. So let me call here x, for instance, from here to here. Okay, so tan alpha will now be opposite over adjacent, and my opposite is y over adjacent is now 15 plus x, the total distance. 15 plus x. Okay, which means I need to get y and x independently and plug it into that equation. That's the only case I can get my tan alpha. So consider the smaller triangle now. This triangle here, this is right angle. Where here is now 24, here is x, here is 40 degrees, here is 50 degrees, and here is y. Now, if I want to get my y now, I'll have opposite. I'm making reference to this angle now. Let's say this angle. I'll have opposite over hypotenuse, which is sine 50 degrees is opposite. My opposite is y over hypotenuse, which is 24. So cross multiply, y is 24 sine 50 degrees. So y will give me 24 times, let us get sine 50. Sine 50. Sine 50 will give us 0.7660. So y will now be 24 times 0.7660 to give us 18.384. I have got y. Now let me get x. If I want to get x, here is adjacent over hypotenuse. So I will have cos 50 because adjacent over hypotenuse will give me cosine. Will be adjacent x over 24. Cross multiply, x is now 24 times cos 50 degrees. Okay, so x will now give us 24 times, let us get cos 50. Cos 50 will give us 0.6428. So multiply, x will now be 24 times 0.6428. That is 15.42.43 Newton. Okay, that is my y. This is Newton also. Okay, this is x. Now, to get the angle finally, tan alpha will now be y. What is y? Y is 18.384 over 15 plus x. Our x is now 15.43. This is the same thing as 18.384 all over. If I add together, I will get 30.43. So tan alpha will now be, we add 18.384 divided by 30.43. This will give me 0.6041. So that the angle will now be tan inverse of 0.6041. This will give me tan inverse 0.6041. That is 31.14 degrees approximately. So the resultant vector is this in the direction 31.14 degrees. Okay, now take a look at the original diagram. Where we have something like this. I have 15 Newton and 24 Newton. 24 Newton here, and the total angle between them is 50 degrees, and I call here alpha. Okay, and that alpha, finally we find out that the alpha is 31.14 degrees. Okay, so this is the angle the resultant is making with the 15 Newton force. Okay, the angle the resultant is making with the 15 Newton force. If I want to get the angle the resultant is making with the 24 Newton force, I will just remove 31.14 from 50. Let's say this is beta. So the angle beta which the resultant is making with the 24 Newton force will now be 50 degrees minus 31.14 degrees. At the end of the day, you will see it will give you around 18.86 degrees. That's just it. If you've enjoyed what you've watched, kindly subscribe to my channel to be notified whenever I upload a new content. Thank you.